Okay, thank you so much. That was great. So do we have some questions online? Thank you, Henry. That was a really good. Actually, I had looked at that before and I read the paper, and the talk actually answered all the questions I had stored up. So we better have some other people have some questions, because I don't have any left. I was going to ask
I'm
about
glad to hear it.
why Robinhood, or why why not Cuckoo or whatever. But I think you've got that covered. So who's asking out there? I can't see at the moment. Ah. Okay. Oh yes, we have a question now. Sorry, I'm just trying to. Oh, there we go. Sorry, I'm just being stupid. Rohan, please start video. Yes, you should be able to do that and say your question, please. Thank you.
Hi, nice work. My question is that I was wondering how big can the Xenix Robinhood data store be while realizing its benefits? Because I want to know how big the NIC's cache is compared to the data store on the host. And do you suffer from any cache thrashing or anything like that?
Right, so that's a great question. I think, so it depends basically on the relative size of the NIC memory and your actual database shard in host memory. And then it also depends on the access pattern of your workload. So basically, if you had sort of uniform accesses of a data store that's much larger than the NIC memory, it's definitely conceivable that there could be a lot of thrashing, and that could have a negative impact on performance. So there's no sort of one answer, because it depends on the hardware and your workload.
I see. Okay. Thank you.
We also have a couple of questions on Slack.
Hey, sorry. Do you mind asking the questions?
Well, I have a question on Slack, which I was going to repeat, which is from Rajath Sashidara, but if you want to go ahead, that's okay. Accept it.
Thank you. So I'm Casey, I'm from Cornell, very good talk. So you mentioned a lot of optimization techniques, like avoiding using PCIe and directly use the memory inside the NIC, and also you avoid extra memory, the communication patterns. So I wonder which technique contribute most in terms of saving the latency, because in the paper you don't mention those details. So I wonder you can give us more insights about this.
So you're asking about latency in particular?
Can be general, right?
Okay.
Yeah.
Yeah, I think so. In the last section of our evaluation, we do have sort of a breakdown where we show some different configurations with different levels of optimizations turned on and off. But in general, I would say the sort of largest performance improvement arises from simply having the most efficient protocol. So that would include not having any network overhead for data structure lookups, and then also being able to consolidate operations like locking and validation into a single remote request. Because these systems generally are saturating network throughput, anything that can reduce those network overheads will increase performance directly. And then any sort of additional increase in efficiency from the other operations or other optimizations will further, I guess, lead to a performance improvement, but those are more workload dependent.
I see. A follow-up question is, in that sense, that offloading to NIC is necessary or not? Because I can simply apply the similar technique in the endpoints, then similar benefits can get, right? So
yeah, that's a good question. So I think you're right on some level that given enough, a large enough number of cores on the host CPU, you could achieve, you could implement the same protocol in terms of network requests and achieve the same throughput. I think what the SmartNIC gets you is reduction in latency by sort of avoiding PCIe when possible, and then also a benefit to overall sort of core utilization efficiency by doing some work on the NIC cores rather than only on the host CPU.
Cool, thank you.
Great. There's the question on Slack, I think, is referring to a paper presented a couple of days ago, which I missed, right? You may have seen on Prism. I don't know if you've read the question, Henry, but it's kind of asking at a high level, what do you think about? Is there a comparison between your Xenic work and Prism that's taking a different higher level approach to the overall protocol in question compared with what you do? I think is the gist of it.
Right. So I think just to briefly compare Xenic to Prism, which is essentially suggesting additional RDMA primitives that would sort of, I guess, overcome some of the inefficiencies of pure one-sided RDMA design. You could definitely add more primitives to your RDMA NIC that would address some of the things like data structure lookups. And I think Prism has sort of a design for that in the context of distributed transactions. And I think that would get you sort of a partial improvement. It would improve some of the inefficiencies that exist. I think we take it a step further by also exploiting state on the NIC. So the NIC memory, both to store objects, to cache objects, and avoid PCIe accesses altogether, but also to move logic to the NIC, where it is essentially more efficient to execute there instead of on the host. So that's something that Prism wouldn't support.
Okay, yeah, no, that makes sense. Thank you. And the other question on Slack is, you rely on host plus SmartNIC having the same ISA?
Right. So we don't necessarily expect that. And in this case, when we're offloading coordination or transaction logic to the NIC, it's essentially compiled natively on the NIC. And yeah, I guess we don't propose necessarily a way to dynamically do that sort of relocation of logic, but that would be interesting future work, I suppose.
Yeah, I think yeah, sure. Okay, brilliant. Right, well, we're bang on time, so thanks very much. Great presentation and really good to handling the questions. Interesting questions, everyone out there. Thank you. So we're on to the second talk of the SmartNIC session, and this is a slightly different topic, but obviously we're still using SmartNICs, and in this case, LionFS is about efficient use of SmartNICs to offload distributed file systems with pipelining parallelism. So this is going to be presented by Jong-Il Kim, who's a PhD candidate in School of Computing at KAIST, and a member of the Computer Architecture and System Lab there. So if we could play the video now, that would be great, and then we'll go to Q&A.
Okay, so we have Henry here, and if you have any questions, please raise your hand. I don't see any questions at Slack, but yeah, you can feel free to add questions there. So to kick off the Q&A, I have a question. So how fundamental is it to use SmartNIC? So I see that with SmartNIC you improve latency as well as throughput. But then to me, in hardware-wise, right, you save DMA. You save with SmartNIC, right? You save DMA transactions and PCI transaction, but the SmartNIC CPU core is very wimpy, right? There is also a disadvantage. So how fundamental is it to use SmartNIC in your system?
Right, that's a great question, and I think in terms of a design without SmartNICs, if you had a large enough number of CPU cores on your host, given a certain amount of network bandwidth, you could sort of reach the same throughput that we do with our SmartNIC design. So that is definitely a possibility. but the SmartNICs do offer a potential for latency reduction that you can't have simply by adding more cores to your host. And then the other thing is we sort of found a benefit to putting some parts of the transaction protocol and some parts of execution onto the NIC cores rather than host cores, because they're close to the hardware, basically to the Ethernet hardware itself. We measure sort of a lower overall computation cost rather than compared to a pure RPC design.
Okay, so Che, I think yeah, please feel free to ask questions.
Yeah, hello, Henry. Thanks for the great talk. I'm Ino from NUS. Yeah, so you say that due to the limited resource of the SmartNIC, we should be careful and we should selectively offload the operations to the NIC to utilize the SmartNIC's resource as much as possible. So I'm pretty new to this SmartNIC technology. So could you introduce some representative transactions or operations that would be good to be uploaded to the SmartNIC or bad to be uploaded to the SmartNIC? Yeah.
Sure. So that's also a great question. And I guess you don't necessarily have to think about anything specific to SmartNICs, but in order to handle execution on the NIC cores rather than the host cores, that generally involves moving logic from the application to the NIC. And that logic may depend on, first of all, it might be computationally intensive. So it might be, a CPU bound workload. In that case, putting it onto the wimpy cores of the NIC would be a bad decision. And then the other thing is the workload might depend on external state sort of data that's outside of your key value store. And if you move the work to the NIC, then you'll have to transfer that state over PCIe. So essentially, if you're sending a large amount of data with each execution, that could result in your PCIe bandwidth becoming the bottleneck of the system.
I see. Thanks for the great answer. Yeah, thank you.
So how sensitive is the type of the SmartNIC? So you use liquid I/O, right? But there's a bunch of other SmartNICs, right? Can you use other SmartNICs? I think that's in your paper.
Right.
But why don't you talk about?
Yeah. So sure, I'll happily explain that. So hopefully there will be other SmartNIC platforms that have the same sort of positive characteristics that the liquid I/O does. In our case, we found that some of the common choices out there, like the Bluefield, have sort of one issue that is pretty fundamental to our design that makes them not a great fit. And that is essentially the overhead of communicating between the NIC cores and host memory. So for the Bluefield, to access host memory from the NIC, you essentially are issuing an RDMA operation from the NIC cores to the host cores or to the host memory. And the latency of doing that is generally higher than an external RDMA operation that's coming in over Ethernet. So basically the cost of communicating between the NIC and host memory is very high, which adds a lot of overhead to operations where the NIC cores need to access host memory. And if that's the case, then this design doesn't make as much sense.
Is it Bluefield 1 or 2 or 3?
So our evaluation was on Bluefield 1. And I know that the architecture for accessing host memory with the Bluefield 2 is not the same. And it might offer some more flexibility, but I think that's something I'll still have to experiment with in the future.
Sure. Is there any other question? Okay, I still don't see. It's still early in the morning. So Korea is far east, and
right.
Other Asian countries are probably it's too early. So I don't see any other questions.
Oh, I see.
So
there's one more hand.
Oh, okay. Who is that? I'm sorry. I don't see.
Maybe it's gone.
I don't understand. Okay, so then I think we can talk again at the mini panel.
Sure.
Okay. Thank you.
Okay, thanks.